important in operating system, any computer system. Instead, user ID or group ID or ID number. Programming counter. What is a programming counter? Program counter. How many programs? You learn in your, it's a data structure. Which class? Microprocessor class. PC. Do you remember the PC? Program counter. Where is the next instruction? It has the PC. Now, do you remind that, right? So that is because, for example, he waited 10 minutes, then the meet again. Do we need to start again? No. Where am I? Probably ask. Then we talk about this one. So that is the programming counter. And register. So Professor Lee locked down the plan, whatever. Then stop and wait 10 minutes and bring it back the note, current status, current image of the CPU. To restart later for advising, we need to have the certain current image of the discussing, current image of the processing in the CPU. That is called the register. All register information will be copied until when? Terminated. And memory limit and the list of open file, all of them will be discussed later. Okay? But these are the incomplete list of the information given by the PCB, but we need. Okay. Then I mentioned that the process cannot use the CPU time all the way the end of the process life termination. Instead, it will be changing from time to time. That changing is called the CPU context switch, which is where's the context switch? Probably later. This is called the context switch. Whenever next student and next student coming and next, that is called the context switch. What happened? We can use the PCB information. Okay? Well, why? PCB has all the information about the process. PCB has all the information about the student. Then student, next time, I can check the PCB. So first, this is a current process, current student. Then stop, next student. At that time, save all current discussion. Save all the information about the process running on CPU. Where? Using PCB. Okay? Then bring the next student, next process, and load into the CPU and everything operating system. So, and reload state of the next process. Then we can do the process and so on. There might be gap because during transition time, so maybe 10 seconds, so I cannot advise. We cannot avoid such a time. Okay? Because of that, even CPU cannot be 100% except infinity loop. Okay, question. This is called the context switch, like the change the student for advising. The more context switch is better or not?
Yes.
Yes or not?
Up to some extent. Up to some extent it's good, but otherwise it's gonna take some time to save the. Every time if you switch the process, it consumes some time.
Which means I will give the second tip to answer my question.
To execute
Many
process.
First, I try to give the hint to answer. Second tip, many of my question can be answered as depending on. As he answered, it may be good, it may be not. So if you have more and more, the context switch means it will be fair, right? The more students have the chance to meet the professor, right? It's a fairness. However, I can use the 10 seconds, then to change the student 1 minute. Meet the 10 seconds, 1 minute. So it's a waste of time. So the more the context switch you have, the performance is not good. Okay? So you need to find optimize. Okay, that is another tuning point. So with the system. Okay, so that is a context switch. We will discuss that part in the scheduling also. This is the real data structure of the PCB. You see in the Linux, you can see there is a struct and task underbar struct name of PCB. You can see the variable. For example, this is a state, and this is a PC counter, and each process has a priority. Like if you are using the task manager, it's a highest, higher, normal, and so on. It's a priority, and some flag and the memory information and so on. So it's actually used in most of the operating system. Okay, then one more thing, thread. Have you ever heard about thread? The where especially? Java. Java uses thread. How many processes will be created when you learn the Java application? Only one process. No matter how many the Java application will run. That is Java virtual machine. Okay. Then what is a thread? So if we create the Java application, Java uses the same API, right? They share the most of the same Java object. So if he is using printf, the string object, do you need to load it again? It's a waste of space. So Java virtual machine take care of all of this for the shared. So we try to share as many as possible from the process data structure. For example, programming code, Java programming code is the same thing. Okay, global variable, if it shared such a variable, share as much as possible. Okay, then only different part, it will be allocated to the memory that is called the thread. So thread can save the memory space. Okay, then reduce the CPU load. Okay, so to do that, we need to talk about the details of thread in chapter 4, next chapter, next week. Okay, so then we will continue from the scheduler. It's just an overview of the scheduler. Then will be discussed detail in chapter 5. Mostly next class we will talk about how we are going to finally create the process. That will be your main job of project 1. Then how can we communicate among the processes? Because we have, except the MS-DOS, we have multiple processes. Any question? Okay, thanks so much. We will see on Wednesday. Please bring your own laptop, okay, for exercise lab. And there's a view of the homework.